Hello, this is Miss Moore, and today during chemistry we're going to discuss the ideal gas law. Today's essential question: when is the ideal gas law used and how? Before you proceed with today's lecture, make sure you have available your handouts, your reference tables, and your calculators. Here we go. Ideal gas law. The ideal gas law is the result of a combination of the simple gas laws. The ideal gas law is used to determine one of the four variables when the other three are known. Okay, that's kind of important. Again, how would you know when to use the ideal gas law? Well, when you have three of the four variables and you want to determine the fourth one. So that means you have one, you know about a pressure, a volume, a temperature, or a mole, and you're trying to find the other ones. Most gases obey the ideal gas law under what we call ideal conditions. So what are ideal conditions? At temperatures above 273 K, which is above 0 degrees, wow, I don't know how to write. Let's try that again. Above 0 degrees Celsius, and at pressures of about 1 atm or lower. All right, so the equation for the ideal gas law is PV equals nRT. So what's PV, N, R, and T? You know all of them, I think, but one. Let's go through these real quickly. P stands for pressure, and what's really important here is that the pressure unit must match the pressure unit for R, and we'll get to R in a few minutes. But keep that in mind. When you're picking your R, the pressure unit must match the pressure unit for the R you choose to use. V is volume, and for the ideal gas law, the volume has to be in liters, not milliliters, not centimeters cubed. It has to be in liters. And again, that has to do with the R. The unit, there's a liter unit in R, so we have to make the volume in liters. Okay. N is the number of moles, and T is the temperature in Kelvin. Now let's talk about R. R is the ideal gas constant, and it is the same for all gases. So what is the number for R? Well, R can be 0.08206 liters ATM, mole to the negative 1, K to the negative 1. And what that means is this. R equals 0.8206 liters ATM, mole over mole K. Okay. R can also be 62.36 liters torr, mole negative 1, K negative 1, or R equals 62.36 liters torr, mole over mole K. So what's the difference between these two R's? Not much. The difference is the pressure unit, ATM and torr. So to pick which R to use, if when you read your problem, you have a pressure unit of ATM, you will use the 0.8206. And if your pressure unit is in torr, you will use the 62.36. Now, if your pressure unit is in PSI, kPa, something else, you need to convert that pressure unit to either ATM or torr, and then use the appropriate R. All right, we need to talk really quickly about this thing called STP. What is STP? STP is standard temperature and pressure. So again, STP, standard temperature and pressure. So now, what is standard temperature? Well, easy. Standard temperature is 273.15 K or 0 degrees Celsius. And standard pressure, 1 atm. Okay, you need to know what is meant by STP. You need to know that standard temperature is 273.15 K, and you need to know that standard pressure is 1 atm. Okay. And at standard conditions, STP, 0 degrees Celsius or 1 atm, Many real gases behave as an ideal gas. And we'll be talking a little bit later about the difference between real gases and ideal gases. But for now, know, again, that at STP, many real gases behave as an ideal gas. And all we have left is to try using the ideal gas law. So here's our problem. Calculate the volume occupied by 0.845 moles of nitrogen gas at a pressure of 138.71 atm and a temperature of 315 K. Okay. If you can, hit pause and see if you can do this without me. If you don't feel comfortable, then just follow along. Right. So the first thing we need to do is figure out which of the gas laws apply to this problem. Now, obviously, for this particular problem, you already know that it's the ideal gas law because that's in the title. However, let's practice how you'd be able to tell. Look at the question, see what they give you. We know that they ask for the volume, that's our X. They give us moles, they give us pressure, and they give us a temperature. So what do we have here? We have 3 of the 4 variables, and they're asking, our X is the 4th variable. That means we'll be using the ideal gas law. So let's jot down the ideal gas law. We have PV equals nRT. And I'm going to make a list of our variables. We have P, V, N, R, and T. And let's go through our problem and fill it in. So we have calculate the volume. So we know that volume is going to be our X. Occupied by 0.845 moles. Well, that's our N. 0.845 mole. And we have a pressure of 138.71 atm and a temperature of 315 K. So all we need to do now is figure out which R to use. Remember, to figure out the R, we need to know our pressure unit, which is atm. So now let's go check it out. And it looks like we'll be using R equals 0.0826206, goodness gracious, liters atm mole K because we have atm there. So let's fill in our R. We have 0.08206 liters atm over mole K. All right, last thing we need to do now is plug it in and solve. So we've got PV equals nRT, right? So we're going to have P, which is 138.71 atm. V equals N, R and T. It's really, really important that you write the units, keep track of your units, cross them out, because as the problems get more difficult, it's really easy to get lost unless you're following your units. So let's see if we can get rid of this stuff on the bottom. And it looks like we can cross out mole with mole and K and K. Cool. All right, so let's rewrite our problem. I'm going to go up, I have more room there. So I have 138.71 atm X equals 21.8425 0.3205 and liters ATM. All right, so now I'm going to get rid of that bottom stuff so I have a little bit more room to work. So now let's solve for x. We'll do that by dividing both sides by our pressure here. Those cross out, leaving x alone. And our ATM pressure units cross out, and we're left with liters, and we were looking here for volume, so we did that right. So now we just need to divide. And I got 0.157467525. We still have liters left, so liters. Last step is to check our sig figs. So we have, here we have 5 and 3, and this is a constant, so we don't worry about the R, and 3. So it looks like we're going to end up with 3 sig figs in our final answer. That 0 is not significant, so we just count the 1, 5, and 7. The 4 is 5 or smaller, so it drops, which means our answer is 0.157 liters. And there you go. That's how you solve problems using the ideal gas law. That's it for today. Have a good one.